back to Abra Knowledge channel. This is a follow-up video to my previous video on equivalence. And in this equivalence test, we're going to do it in DATAtab. In the previous video, we did it in Minitab. So the same data set I have, and also the assumptions also same. We're going to do this hypothesis testing using equivalence model in DATAtab. Let's learn how. I have this data, and all I'm doing it, I'm just pasting the data in DATAtab, and this is the data I have, and all I'm doing it. So selecting this variable, let me do it from beginning. So I have just selected, I've just copy pasted this data. Let me go back, copy this data from the Excel, and this is coming from Minitab, the data set. I'm then pasting here. So this is all the 4 columns being pasted, and it is showing the metric as these 4 are the metric. Now what I'm doing it, I'm just comparing group 1 generic and group 2 generic, right? These 2 medicine, I'm just checking it, and I have selected something called equivalence and non-inferiority, and go further down, and the same tolerance level minus 0.1 to plus 1.1. I'm just going for t-paired test, so it is automatically giving this one. This, since it is only one paired one, and you can see here test for assumption. This is already, it has given the interpretation also. This also has given AI interpretation, artificial intelligence. This table shows the result of 2 different statistical tests used to assess whether your data follows normal distribution. P-value, high p-value greater than 0.05 suggests that the data does not significantly deviate from the normal one. And as you can see here, the data is normal, and we'll see the interpretation one. So now this is there are 8 data set, and this is the mean 4.19 and 3.77 standard deviation, standard error of mean. Standard error of mean is you have a standard deviation divided by square root of n. And then another one, it has given the box plot very beautifully, it has given. And then you can also, you have a freedom to even include that standard deviation also, or without standard deviation. If you wanted to have the show points, you can have, and you can see that the dispersion is too high here compared to this. And even you can make it large also, or extra large also you can make it. So I'm happy with the medium. And correlation, you can see that correlation between these two is given here, negative correlated, and again the weak correlation because it is less than 0.7. And then you can see here degree of freedom, because since we are talking about 8 data, and this is a degree of freedom, tail value and p-value 0.28. And then you can see the confidence interval, and very importantly, the equivalence using those 2 one-sided tests, right? Low boundary, how much it is at 0.96, and upper boundary is 0.8. In both the cases, it is greater than 0.05. That means we have to reject. We have to accept the null hypothesis. That means there is 2 are almost same one, right? And similarly, what I'm doing it now, so I have selected one group now. Let me do it another group. So this I have selected generic and generic. Now this time I will do group 1 generic, and the same thing group 1 band. So let me see if within the group 1 band and generic are having any significant difference. So this is another test we are doing it now using this one. Again, I'm just doing the same assumption. Of course, it's a t-test, and you can see that group 1 is here, and group 1 band is here, right? Sorry, brand is here. And similarly, you can find that p-value, it is very strongly correlated. Whether it's a group 1, whether you take generic or brand 1, they strongly correlate. That's a very good news. And the p-value is very significant, right? Very less than 0.05. And this is in this experiment, we are just proving that whether it's a brand, or whether it's the generic, both are strongly, I mean, both are having significant difference. As you can see, the mean value also having differences among between both. So similarly, what I'm doing it, I'm just selecting the other set, that is group 2 and group 2 generic, right? And let's see the same thing. We're gonna go ahead with this one. It has updated automatically the values, and then this is also yet again 92%. This is strong correlation, and the p-value is very significant, and so on. Right? You can see here. So this is the value 0.4, and now here we're talking about confidence intervals, and it also is given that what to check everything, right? And so similarly, we can also do whether within that group. Now we know that within the group it is having that the differences. Maybe what we can also do, that we can just now we can, instead of try, we can try if the generic is having any impact. So you can see generic. So you can see that the values greater than generic is not significant difference, right? Maybe we can try for brand. Let's see the p-value. Again, brand is also not having impact. The only impact what we see here is that between group 1, whether within the generic or the brand you take it, it is having the significance. So like this you can do that, and we can also get to know the other chart also as well. For example, let's say I'm just giving a descriptive. It also offers the other charts also as well. Let's say I'm just selecting all 4 variables, and you can see here the pH value. This is a, and you can see all this it has given. And even if you want, along with the standard deviations you have here, even along with the confidence interval, standard error, everything it has given. And then you can also find it whether you want the horizontal or vertical and all that. So this is first one is a mean bar chart, the other one is scatter. In scatter also you can change it to frequency, that will be more better. And you can see that group 2 easily we can make out is having the values are largely between these two, right? The pH value is between 4 and 5, right? And then similarly, this is all about this one. And let's say if you want the bell curve to it, you can just select the normal distribution, and in the normal distribution it will come. So okay, and then you have box plot. In the box plot also it has come for all the 4 categories: group 1 generic, group 1 brand, and group 2 brand, and group 2 generic. And then Valen plot also it has given, and rain cloud, and then quartile to quartile plot, and line chart, and so on. So it has given very beautifully. Like this you can also play around with this one. We can also do, for example, cluster also you can do. If you have any cluster pattern between these two, we can get to know is there any cluster pattern is having, so we can get to know easily, right? And maybe how many clusters we can form, and then we can try to do that also as well. And we can also do other things also, like decision one, because it's a variable data. Like this you can do other tests also as well. For example, let's say if you want to know the pH, the process capability, we can also do the process capability for this also as well. Let's say it's 0 to 1, and you can get to know the values very fast. So like this you can get to know anything, everything very fast using this model. It has given a process capability with the IMR chart, and what is the lower and upper value, and what is the pH value, everything it has given. Like this you can also change it to group 2 also as well, and then you can get to know the values. Also you can see here, so values it has come. And similarly, you can play around with this data, and in Minitab, you have to know the navigation first. But here, when you select it, automatically it gives the values. And I hope you find it useful. Please do like, share, subscribe my channel. You have a wonderful day ahead.